everybody. We are now on lesson 2.3. Is it a function? And my name is Miss Mitchell. All right, so we learned in 2.2 what is a function, but now we need to determine, is it a function, right? And you might be wondering, well, yeah, we just learned about it. But we actually have two vocab words here that are going to teach you the difference between what is and what isn't a function. And a relation connects an input to an output. So basically, this is saying we get an x and we get a y, right? They're connected to each other. So this is a relation, okay? But a function is actually a type of relation. Right? So a function is actually a type of relation, but it's a special relation in which each input only has one output, okay? This might seem a little confusing right now, but as we continue, you guys will understand and be able to decide if it's a relation or if it's a function, okay? So now moving down, it says, is it a relation or is it a function? And in order to do this, we're going to create a mapping diagram of each relation and use the diagram to determine the relation is a function, all right? So it shows us an example over here with our inputs, and we have our outputs. And you may be wondering why these lines are crossed. Well, that's because when we write this mapping diagram, we write these in order from least to greatest, okay? So that is why we have some crossing lines here, because we are not necessarily writing it in the way the ordered pairs were given to us. We're writing it in least to greatest, all right? So let's move down to example 1a, and we've got these different ordered pairs right here, and we're going to write our domain and our range. Remember, our domain is just our x value, and our range is our y values, okay? So we know that ordered pairs are written in terms of x comma y, all right? So that means all of our domains are going to be these first numbers, but let's write it in least to greatest. So we have 3, 5, 7, and 8, okay? Then our ranges here, we have 7 twice, so we only have to list it once. So we have 6, 7, and 9. Now, on this particular example, we're not going to worry about is it a function. I just want to make sure you guys are understanding how to map the diagram, okay? So we have 3 and 6, we have 5 and 7, 7 and 7, and then 8 and 9, all right? And now, for example B, we'll write this. We've got some decimals, but nothing changes. But notice that we do have two x values, okay? So we'll have 0.3, but we only have to write it once, 0.4, and 0.5, okay? And our ranges here are 0.5, 0.6, 0.7, and 0.8, right? Well, we have 3 connecting to 0.6. We have 4 connecting to 0.8. We have 3 connecting to 0.7. So we'll make another line from there. And we have 5 connecting to 0.5, right? So this is how we map the diagrams, okay? All we're focusing right now is on how to map the diagrams. And now we're going to determine on the next examples, well, is it a function or is it a relation, okay? So, quick fun video that I found on TikTok that I want to show you guys. Let's see if it'll pop up here. Might have to zoom out of my screen first. Here we go. So let's watch this video and see how this teacher explains, is it a relation or is it a function?
Is the relation a function? All you have to do is see. If you catch a girl cheating, it's no fun or not a function. So this first one, 3, the girl comes first, right? 3 is dating 4, 5 is dating 7, 6 is dating -2. You did not catch a girl cheating. This is a function. But the next week, I see 3 dating 4 and I see 3 dating -2. This girl is cheating. This is no fun, so it's not a function. We don't care that these boys are dating all these girls. The boys are allowed to date whoever they want. Not in real life. But this is still a function. And this one, this 3 is dating 4, and then 3 is dating 4 again. She's not cheating on her boyfriend. She's just high maintenance. So that is still a function. And then 3 is dating 4, and 3 is dating -4. She's going to try to tell you that she can't tell that they're different. But she knows. She knows they're twin brothers, and she's totally cheating on her boyfriend. This is a no.
All right, so this is just a fun way for you guys to remember, well, is it a function or is it not a function? Give me just a second to get everything pulled back up. So what she was saying was that in this particular case, she's treating all x values as the girl and all y values as the boys, okay? And basically what she's saying is, let's go to a blank page here. All x's must, no questions about it, be different. This is if it's a function, all x's must be different. Ooh, how do you spell different? It's just totally messed up. Okay, and then, because this was our girl, right? So if she's cheating, it's not a function. So they must be different. You can't have two x's. Even if they have different y values, the x's must be different, okay? But then it tells us that the y values, can be the same, right? So think of your y values as your boy. So the girl can only have one boyfriend, but the boy can talk to whoever he wants. Obviously not in real life. We're just using this as an example for you to understand, is it a function or is it a relation? All right? So now that we think about that, let's keep our notes here where we know that x's must be different and y's can be the same. Okay? So now let's look at what we've got going on here in example A. So notice we've got 3, -1, 2, 0, 1, 2, and 9. Okay, well, we know that these are our x values, and we notice we have 2 here. Hold on. We have 2 here, and we also have 2 here. All right, so we really don't have to look any further. This is not a function. Right? Because our y values are different, but even if they were the same, this would still not be a function, right? Because we have two x's that are the same. Right, now let's look at B. Okay, well, we notice we've got -8, and we've also got -8 here. But it's the same point. So in this particular case, she's not cheating, right? She's dating the same guy. So this is a function. But here, she's dating 9 and she's dating -8, not a function, right? All right, now let's look at C. Do we have any x's that are the same? No. But we do have some y's that are the same, right? Because don't forget, f of x is just a fancy y, okay? That's why we have h of x, f of x, but it's the same thing as y. Well, we wrote this little note up here that y's can be the same. So we don't have any x's that are different. So what do you think? This is a function. Okay? Last example that we're going to look at right here. We've got button number and type of candy. All right, so let's just treat this, just because it's got names doesn't mean it's any different, okay? This is our x value and this is our y value. All right, so let's look at our x's. Do we have any that are the same? Okay, yeah, well, we've got 1, those are the same, and we have 2, and we have 2. All right, so now let's look at our y's. Well, on these 1s, we have sticks. Okay, well, in this case, she's not cheating, right? This is the same. So the plot on the graph would be the same. But if we're looking at 2, we've got M&Ns. I don't know if that's a typo, if we can't use the real word here, or duds. Okay? Well, these are different, right? So she is dating 2 different guys. These are not the same. So what that tells us is if we have a girl dating 2 different guys, this is not a function. Okay? I know it's kind of a crazy analogy, but it will help you remember it, okay? If it bothers you, you can flip it around, all right? You can call the boys that and see if he's cheating. But either way, if our x's have the same value, it's okay. But if our x's have a different y value, it's not okay. It's not a function, all right? Feel free to pause it and take your notes if you missed any of it. All right, so let's keep going. All right, once again, is it a relation or is it a function? Well, your number one friend here would be the vertical line test, all right? So it says, imagine drawing vertical lines through the graph. If the vertical line touches the graph at one point, it is a function. But if the vertical line touches the graph at more than one point, it is not a function, okay? I'm trying to see if I can get a line here. I don't know if it's possible or not. Can't move that around, okay? Never mind. So imagine taking a pencil and running it straight across your graph, okay? And if you're touching more than one point at a time, then it will not be a function, all right? So let's look at it. Imagine, it says, is it a function? Well, imagine taking your pencil and taking it vertically across the paper, right? That means up and down. All right, so we're touching it. Do we have any points that touch the lines, right? So imagine this being our vertical line. Do we have any point where this touches more than one spot on the graph? No, we don't, right? The lines are only touching one point at a time. So this is a function. All right, now it says create a table from the graph. So let's just look at some ordered pairs here, okay? We can just go ahead and dot these off. So we have that one. Let's look at -2. We've got one there, one here, one here. We could go down, but I don't think we have much room on that table. All right, and then we're just going to plot these. We know that our x's go on the top and our y's go on the bottom, and we're going to write them in order from least to greatest, right? So remember, negatives are always less than your positive numbers. So we're going to have -3 and 0, -2 and 1, -1 and 2, right? Remember how to graph, -1 and 2, 0 and 3, 1 and 2, and 2 and 1, okay? So let's just fill up our table. We don't have to go all the way across. Let's just fill up our table. It says, does each input only have one output? Well, let's look at it. All this is saying is are all x's different? Well, we already know this is a function, but let's check it. Do we have any x's that are different? That are the same? Any x's that are the same? No. So we have all different x's, so we know from not just the vertical line test, but also from our mapping diagram that this is a function, okay? Now let's keep it going. Now let's look at B. All right, well, it says, first things first, is it a function? Well, imagine taking your vertical line, take your pencil across the screen, pause it if you want to, and just move a vertical line across this graph, right? So we have a dotted line here, right? So if we had a vertical line, I don't know why this does this, I'm sorry guys. So if we had a vertical line here, we're touching 2 points, right? If we had a vertical line here, we're touching 2 points. And just like the vertical line that they already had drawn for us here, we've got 2 points. So that tells us that no, this is not a function, okay? Now let's create a table from the graph. So let me clear this off and let's make some points, right? So I've got a point here, here, here. I'm just going for the easy ones that are on some specific lines here. All right, so now we've got our x's and y values, right? We have -3 and 0, -2 and 1, -2 and 1, 1 and 2, and 1 and -2, okay? And we're just going to leave this one blank. So we already know, based on the vertical line test, that this is not a function. But let's just double check it. It says, does each input only have one output? Which is asking us, like I said before, are all x's different? All right, well, let's just look at it. We know we've got -2 here. We've got -2 here, so we already have more than one x repeating, but we also have 1 and 1, right? Well, let's look at it. We have -2 and 1, -2 and 1. This is the same, so this is okay, right? No cheating going on here. But we have 1 and 2 and 1 and -2. This is not the same. Despite the number being the same, that negative sign does change it, right? So not okay. So just even further states that this is not a function, okay? All right, now it says to use the vertical line test to determine if each of the following is a function. I really wish I had some sort of line to draw across here for you, but let's just draw some vertical lines on here, okay? So we're coming across with our vertical line. That's a really bad vertical line, but we're only touching one point, so we're good. Right, but now we're right here. Oh, we're touching one point. Oh, we're touching another point, right? So we're touching 2 points at the same time, which tells us this is not a function, right? All right, now let's keep going. Are we touching any other points right here? No. Touching any other points right here? No. Not here. Not here. And not here, right? So none of these are being touched at the same time, which means that this is a function. Okay? Let's look at C. So imagine taking a vertical line and drawing it across. So let's just do a few examples here. Vertical lines. Are we touching more than one point at any time on this function? We're touching 1 point here, 1 point here, 1 point here, and 1 point here. So even though it's kind of a different looking graph, it's still a function, right? This is a function. We're not touching any more than 1 point at a time. Okay? We just have a few more, and then you guys will be sit on your own to work on your practice. So let's finish these last 3. All right, so it says, still using the vertical line test, is it a function? Well, let's see. All right, well, here we're touching a point, we're touching a point here, we're touching a point here, and we're touching a point here. So we don't even have to look at the other lines if it happens at all, right? We're touching all of these points at the same time. So if it happens at all, you don't even have to check again. This is not a function. Okay. Now let's check this one. So let's draw a couple of vertical lines. All right, so we're touching 1 point, 1 point, and 1 point. So this one is a function. Okay. All right, last one we're going to look at, and then I'm going to send you guys off to the real world, is just a circle, which was pretty obvious, right? So we're touching a point here, and we're touching a point here, right? So we're clearly touching more than one point. You can even highlight it here. We're touching more than one point. So this is not a function. All right, all you guys need to do now is work on your practice problems. If you guys have any questions, reach out to your algebra teacher. They'll be more than happy to help you. And once you're done with this, make sure you complete your practice online, filling out all of the answers, okay? Wish you guys the best. And if you have any questions, please let me know. I'm always here to help, and so is your